Here we have a question. In this question, we have to find the radial and transverse component of velocity of rocket when it is at an angle of inclination 60 degree as shown in the figure.
Before that, let's understand what is radial velocity and what is tangential velocity, or we can say it as transverse velocity. So radial velocity is velocity of particle which is acting in the direction of radius vector. So here, as we can see, this is the radius vector in this direction, and now we will find the component of this velocity in the direction of radius vector. This is going to be our radial velocity. And the transverse velocity, so the transverse velocity is perpendicular to the direction of radius vector. So as you can see, if you take 90 degree from here, we can find that in this direction, this is the direction which is perpendicular to the radius vector. So from here we can call it as transverse component of velocity. So now let's move forward.
Let's see what's given. The path that the rocket is following is a parabolic path with a equation y equal to 600 minus 35 x square, and the instantaneous velocity of the rocket which is constant over the path which is 800 meter per second. The angle of inclination is 60 degree at this moment, where we can write and we can differentiate the equation y equal to 600 minus 35x square with respect to x. From here we can get dy by dx, which is change in an inclination, which can be said as change in inclination. So it can be written as tan theta dash equal to dy by dx equal to minus 70x. As we know, this would be the instantaneous angle theta. So the transverse and radial component of velocity can be written as v cos phi and v sine phi. As we know, this is the instantaneous angle phi, which is 180 degree minus 60 degree minus theta dash. Means this is the change in angle. So the transverse and radial component, the radial component of velocities can be written as v cos phi, which is v cos 180 degree minus theta dash minus 60 degree, and the transverse component of velocity is written as v theta equal to v sine 180 degree minus theta dash minus 60 degree. So as we know the value of x by y, from here we have the relationship between y and x. Now we will substitute this value of y in equation number 1 and find the value of x. So at this point dy by dx can be written as minus 288.1. So means here, from here we can calculate the value of theta dash, where theta dash tan theta dash equal to minus 288.1. From here, taking inverse, we can find the value of theta dash equal to 89.8011 degree. So now let's substitute the value of theta dash and get the transverse and radial component of velocities, where radial component of velocity Vr can be written as V cos 5, substituting all the values, V as 800 meter per second and cos 5 as cos 180 minus theta dash minus 60 degree. It comes out to be 691 meter per second. Now let's go and find the transverse component of velocity, where V theta equal to V sine phi, where sine phi is written as sine 180 minus theta dash minus 60. Substituting the value, we get the value of V transverse as 402 meter per second. So here we find the transverse component of velocity and the radial component of velocity as 402 meter per second and 691 meter per second respectively. Thank you.